Hi everyone and welcome back. So to add more fun to the existing application, what I did is I introduced the MongoDB database and we will be writing, reading to the database. We will introduce some more models. Let's first talk about the cat model. Okay. So here I did the MongoDB connection. I mean, it's like the same typical Node.js code, mongoose.connect, and I am running MongoDB locally. It is fine. I will just zoom it a little bit. Okay, now what do we have is we have our resolvers and type definitions. So let's add some more type definitions to this. We have hello and remove all these things. We don't need them. We will make it cat centrics cat, and this cat will return a single cat. Okay, so cats is going to do the find in the database and return all the cat. And here we have create cat. We can remove this user types for now. So cat needs id and name. In the create cat we are passing name. So similarly you can actually write other mutations like update cat, delete cat and all. Let me just minimize this. So if I just call it as an update cat, then instead of id you will be, instead of string you will be getting the id. Update cat and delete cat. Here also you will be getting, I mean it's just a string, but yeah, that would be required. And we'll be returning, what should we return in case of delete? Nothing else, like true or false. You can just say. So that is boolean we are returning. I think it should be capital B. Update we are returning cat, and then query, right? In the query what we can do is we are returning all the cats. Okay, and there can be another method like get cat by id. That can be another query we have. So if we just look at the, okay, so here we got we can actually trigger the create and all these things. So let's go to the code again. So we have exposed all these mutations. So we have to write it in the resolvers, create, update and delete. So create we already have. We have to introduce few more. Cats we already have, so but in this case we will be just returning the data from MongoDB, not from here. So first of all we will make it async. So here we have all the three methods: create cat, update cat and delete cat. Delete is nothing but find by id and remove, and it is returning the boolean. The same spec we have defined in the type definition, that delete cat is returning boolean, update cat is returning cat object, create cat is returning cat object. Now if we just see this by running it on the our playground, so how it look like. So here is our playground, and here we can just see this query, send request, we are getting all the cats, right? This is the query we have. If we go to the documentation, then we can also check on the mutations like create update cat. We can copy this id, and then we are adding this mutation. So we are passing the id and the name which we want to update, new name, right? And just send it. So we should be able to update this cat data, right? We can also delete it. For delete, what you need to do is delete cat, and we are not getting any response, it's just returning the boolean, so we can't expect any argument. So we just remove this and we will just send it. So it will delete it and it will return the boolean, right? So this is how it is working. Whatever we have written, we have seen that, okay, this is how the GraphQL query is working. We are able to trigger the query mutations based on our documentation. Okay, now coming back to the code, here now we see that this is the MongoDB and this is how we are writing the type definitions and resolver. But is this code scalable enough? I mean, if we keep adding the types and queries and mutations for the same model here, then it will create a problem, right? For cat model that is fine, but our application is going to have dog, animal, other models also, so it's not good approach to combine all the type definitions in a single file. So there is a way you can actually split these queries, I mean schema definitions and resolver for each model in a different folder. Like for cat you will have the cat definitions and resolver, for animal you will have an animal resolver, animal definition in a separate folder, and finally you merge it and pass it to the GraphQL Apollo server. For now let's define it another entity here only. So we have the type definition, we are talking about cat, so there can be another entity animal, and you define the model for the animal like the name and all. So we can do the same thing, same as cat, we are introducing new entity. So here we can expect a name. So the model name is animal, name is string, that is fine. And the type, do we need a type or category of animal? Okay, let's keep the name property only for now, and we have animal. Okay, so what else we're trying to explore is what all different queries we can specify, right? So we have seen all the different kind of mutations and all different kind of queries. So same as the mutations, let's go to our type definition. Like same as this is taking argument, right? So we can define our another method names like simple cat. It can be a simple cat which is taking ID as a string, and you are returning only a single cat, right? Now you have to define this in your resolver, cat taking the ID as argument. So here we will add it in the query section. This will just do the search based on the ID, and here we have these argument. I'm getting ID from the arguments object. I'm just doing this structuring directly, and here we can do the find by ID. Find by ID, and you just pass the ID, so it will return the cat object right away, and we are good with this. Okay, coming back to our other types which we were specifying, like we have the animal is another type, and then now you can, in the type definitions, you can specify animal. So we can also create a enums and all these things. So animal is also have a name and ID, and you can define the methods for animal and the queries for the animal, right? Like animals, which is going to return the type animal of array of not non-nullable list. Animal is already a type we have defined. Now similarly you can define the mutations for the animal, so these mutations will get exposed, right? So our schema can be as simple as cat and animal, and as complex as like a lot of different collections of MongoDB. We are exposing them through these type definitions. We are exposing them through these type definitions like cat, animal, and all mutations and queries. We can also define the union, interface, custom input types, everything you can define here in the type definition. Okay, for now let's keep it simple. So this is about the beginning, or you can say the basics of your queries, of your GraphQL introduction. Now I will go one step upper, one step beyond, and we will have the isolation of these queries and mutations for different models in different folders, and we will merge them together and we'll create a simple APIs, because this is not scalable enough. We are putting all the types and definitions together in a single file. Okay, let's take a look onto that in the next video.